So this video is going to show you how to apply part comparisons to parts that may not exactly line up by default. So I have here two parts. This is the step file for drawing 8-7 that's been imported. You can see it's an imported solid, not a SolidWorks format file with all the features. And so the first thing I'm going to do is change the color of this just to make it a little bit easier. I'm going to click Imported 1. Give it a standard, let's say like a dark color, so now I can actually see what's going on. And so the problem that we're going to see is, let's say I want to compare to this part here. This is an example part. You can see it's missing some features like fillets here. This fillet is the wrong dimension and such. So our part comparison is going to reveal that. So maybe the easiest way to see what's going on is just to directly compare the documents. So I'll assume everything's great. I pick the solution as my reference document. Modified document is this drawing 8-7 part. I'm going to select geometry, align parts by coordinate system, and do run comparison. And so very quickly we can see that something's not right. Like, my model is off, but it's not this off. And if we uncheck the vision, the little goggles up here, it will show all of these at once, and we can very easily see the problem. The issue is that my part is shifted over, and so the comparison is not working. I'm just getting the intersection of these two bodies, when what I really want is for them to both be aligned in the same part. So there are a couple ways to go about this to make coordinate systems that match up. You can make an assembly and have them shift over, but in my experience, I think the easiest way to go about it is to just make two coordinate systems, one in each part, that are easy to draw and easy to mentally picture the orientation of. So what do I mean by that? Let's back out. I'll go to this imported part. So let's say, for example, we want to make a coordinate system based off of this corner and align to each of the edges. So something like that is very easy to do, since coordinate systems are based on, basically it's a point or a vertex and then a combination of axis directions. So if I choose this point, now we can see that the user coordinate system has moved, but by default it lines up with each of these main coordinate directions. So if I wanted to, I could choose this surface maybe as my reference. So I could say, well, if I want this plane to be perpendicular to my x-axis, then I'd make this plane a reference for x-axis. And then by choosing the direction, I could say, okay, point forward or backward. So in that way, I can customize the orientation of my coordinate systems to match whatever I want. For now, however, it should be enough. I don't need any references here because basically I'm happy with z going this way, x going this way, and y going that way. So the important thing is I just selected that vertex as my coordinate system. So now I have coordinate system 1 defined. I'm going to save this part and then switch over to my other part here. So in this part, I have this same corner. So I'm going to create a coordinate system as well. I'm going to choose that vertex. And again, I have x, z, and y in the same orientation that I need, so no problem. And I actually didn't even need to create this coordinate system because it already happened to be lined up. But in case you have to, this will show you how to do it. So now we have coordinate system 1 defined in this part. So we can switch back to our solution part. And now I'm going to go through evaluate and compare documents once more. Same procedure as before, the solution as my reference, the modified document as my version of the part. I'm going to compare geometry. The difference now is I've created these new coordinate systems. So before there was just one. Now I can select coordinate system 1 in each of these. And if I did it right, when I run the comparison, we'll see that now this common volume looks much closer to what we expect. And if I uncheck that vision, now we can get an easy, like a clear depiction of what's wrong with this document. And so from this we can start to diagnose. For example, we can see this brown area here is where my version added material, and we can see I've got material on top. So what that basically tells me is that my part is too tall. We can also see that I've added material around the sides here, which means my fillets are the wrong dimension. These blue fillets in here shows me that if I just show the material removed, we can see that I forgot fillets around the inside. So I left those just as sharp edges. And so you can see very quickly I can get an idea of what is different between these parts. But again, this only works if I have those coordinate systems matching up. So make sure when you're comparing other parts that you do this. It just takes a few minutes, as you saw, but it'll save you a lot of headaches.